Can America's power grid survive the AI boom? An AI data center can use as much electricity as a small city. And across the United States, companies are planning more of them. Much more. That creates a problem most people barely thought about a few years ago. America may be able to build a AI infrastructure faster than it can build the electricity infrastructure needed to power it. For more than a decade, US electricity demand barely grew. Utilities got used to a world where power consumption increased slowly. Then came artificial intelligence. Training larger models requires enormous amounts of computing power. Running those models for millions of users requires even more. And all of that computing happens somewhere physical. Inside buildings packed with servers, cooling equipment, transformers, and networking hardware. Data centers already consumed about 4.4% of US electricity in 2023. By 2030, researchers at Lawrence Berkeley National Laboratory estimate that share could rise to somewhere between roughly 9–15%. In the higher-end scenario, nearly 1 out of every 6 units of electricity generated in America could be going to data centers. But the biggest problem isn't just how much electricity AI needs. It's how fast the demand is arriving. And America's power grid was built for a very different world. Ever one. The grid moves slower than AI. The power grid isn't like the internet. If an online service suddenly gets millions of new users, a tech company can add computing capacity relatively quickly. Electricity doesn't work that way. Before power reaches an AI server, an entire physical system has to support it. A power plant has to generate the electricity. High-voltage transmission lines have to carry it across long distances. Substations have to change the voltage. Local infrastructure has to deliver that power to the data center. And at every moment, the grid has to keep electricity supply and electricity demand almost perfectly balanced. The problem is that many parts of this system can take years to expand. A company can announce a new data center, raise billions of dollars, order chips, and begin construction relatively quickly. A major transmission line can't move that fast. Neither can a new power plant. Neither can many large substations. They have to be planned, permitted, financed, connected, and physically built. PJM, which operates one of America's largest regional power markets, has warned that new data centers can be developed 2 or 3 times faster than some of the power resources needed to serve them. That's the fundamental mismatch. AI moves at the speed of tech. The grid moves at the speed of infrastructure. Drone 2. Texas is becoming a test case. You can already see this problem emerging in Texas. Texas has become extremely attractive to data center developers. It has lots of land, a huge power market, rapid population growth, major technology investment, and access to multiple sources of energy. But the number of proposed large electricity users has become so enormous that grid planners have had to change the way they evaluate them. In 2026, Texas regulators approved a new process for studying large electricity loads. Instead of treating every giant project as if it exists in isolation, Grid operator ERCOT can study groups of major projects together and determine what the system can realistically support. And we're not talking about office buildings. A hyperscale data center can require hundreds of megawatts. At that scale, a single facility can become one of the largest electricity customers in an entire region. Now imagine dozens of companies requesting connections at the same time. Grid planners face a difficult question. How many of those projects will actually get built? If they underestimate demand, there may not be enough infrastructure. But if they overestimate it, utilities could spend billions building power lines and substations for projects that never happen. And somebody ultimately has to pay for that infrastructure. 3. America thought electricity demand had stopped growing. This is what makes the AI boom so disruptive. For years, America's electricity system was operating under a very different assumption. Between roughly 2005 and 2019, US electricity demand barely increased. Energy efficiency improved. Lighting became more efficient. Appliances became more efficient. Some heavy industry moved overseas. Utilities got very good at operating in a low-growth environment. But that era may be ending. Electricity demand began accelerating again in the early 2020s. And data centers are one of the biggest reasons. The North American Electric Reliability Corporation now expects US summer peak electricity demand to grow dramatically over the next decade. AI data centers, manufacturing projects, electrification, and other large new customers are pushing forecasts upward. That changes the entire challenge facing utilities. For years, the question was, how do you manage an enormous grid when demand is barely growing? Now the question is, how do you expand that grid fast enough? Just 4. Building more power plants isn't enough. The obvious solution seems simple. Build more power plants. And America probably will. Natural gas, solar, wind, battery storage, potentially more nuclear. But generating more electricity only solves part of the problem. Because electricity still has to get to the place where it's needed. Imagine a new data center is built outside a major city, hundreds of miles away. There may be plenty of available generation. But if the transmission lines between those two places are already near capacity, that electricity can't simply teleport to the data center. That makes transmission one of the most important bottlenecks in America's AI build-out. Transmission is the high-voltage backbone of the electric grid. It's what allows electricity generated in one place to serve demand somewhere else. But building major transmission lines can be extraordinarily slow. Projects may cross multiple counties, multiple states, private land, federal land, different regulatory jurisdictions. They can face years of permitting and legal challenges before construction even begins. The Department of Energy has warned that the country needs major additions to its transmission system as electricity demand rises. So America could theoretically have enough power generation overall and still face shortages in specific places. The problem isn't only having enough electricity. It's having enough electricity in the right place at the right time. Day 5. Then comes the most important question. Who pays? This is where the AI power boom stops being just a Silicon Valley story. Imagine a technology company wants to build a multi-billion-dollar data center. The local grid may need a new substation, new transmission lines, new generation, maybe major upgrades to infrastructure that was originally built for a much smaller level of demand. Who should pay for that? The company building the data center, the utility, or everyone else connected to the same grid? That's becoming one of the most contentious questions in the industry. Federal regulators have been pushing regional grid operators to develop clearer rules for connecting huge electricity users like data centers. Part of the goal is speed, but another part is fairness. If a new data center creates billions of dollars in infrastructure costs, regulators don't want those costs automatically shifted onto ordinary households and small businesses. Because that's when the AI boom could start showing up somewhere completely unexpected. On your electricity bill. And that changes the political equation. People may support AI investment. They may support new technology jobs. They may support new data centers. But they're much less likely to support them if the local grid becomes less reliable or household electricity costs start rising. So the real question isn't simply, can America generate enough electricity for AI? It's also, who pays to make that possible? 6. There isn't one solution. America probably won't solve this with one giant construction program. Instead, several things have to happen at the same time. First, the country needs more generation. That could include natural gas, solar, wind, batteries, nuclear power, and other technologies depending on the region. Second, it needs more transmission. But new transmission lines take time. So utilities are also looking for ways to get more capacity out of the grid that already exists. One example is dynamic line rating. Most transmission lines operate under fixed limits designed around conservative assumptions about weather. But a power line can sometimes carry more electricity when conditions are cooler or windier. With better sensors and real-time data, utilities can calculate how much electricity a line can safely carry at a particular moment. That doesn't replace new infrastructure, but it can help squeeze more capacity out of existing infrastructure. Data centers themselves may also become more flexible. Some could locate closer to major power sources. Some companies may build their own generation. Others could use large battery systems. And some computing workloads could potentially shift away from the hours when the grid is under the most stress. Not every AI task has to happen at the exact same second. If certain workloads can move from 1 hour to another, or even from one region to another, data centers could become more responsive to grid conditions. In other words, the solution may not be to build an infinitely larger grid around AI. AI companies may also have to adapt to the grid. 7. So, can America's grid survive the AI boom? Probably. But survive may be the wrong question. America isn't likely to wake up one morning and discover that the entire power grid has collapsed because people are using too much AI. The more realistic problem is slower and more complicated. Data centers could arrive faster than new power plants. Power plants could arrive faster than new transmission lines. Transmission could be delayed by permitting. Utilities could overbuild for projects that never happen. Or communities could end up fighting over who should pay for all of it. The AI boom is forcing America to confront something the technology industry doesn't usually have to think about: physical limits. You can improve software almost overnight. You can release a new model in months. You can order another generation of chips. But you can't download a new transmission line. You can't update a substation with a software patch. And you can't build a power plant in the cloud. Those things require steel, copper, transformers, land, permits, workers, and time. For years, the biggest question surrounding artificial intelligence has been: how powerful will these systems become? But over the next decade, another question may become just as important. How fast can America build the physical infrastructure underneath them? Because AI may run in the cloud, but the cloud still runs on electricity.